Okay, guys, let's take a look at Chapter 8. Chapter 8 starts on page 315 in your book, if you guys want to go ahead and follow along with me as I go through Chapter 8 today. As you can tell by the title, we're taking a look at dosage problems for infants and children. We are going to be reminded again of our favorite formula. We've seen it so many times. We saw it last class, and we saw it in Chapter 4 and 5. But our favorite formula, our dosage calculation formula, the D over H times Q, remember standing for dose over hand or dose over half. I'm sorry, I couldn't think for a second. And then multiplying by our quantity. We just so commonly use this formula, and this is something that will be considered in this chapter as well. The reason why we specifically look at dosages for infants and children, as you guys know, children come in a variety of sizes. They also have, because of the fact that their bodies are still developing, their immune systems are still developing, we have to take into consideration that when we are giving them medications. So because of that, we really have to take into account their weight, or what we're also going to see in this chapter is their body surface area, and I'll talk to you guys about that in just a little bit. But what that does is not every child can just take the same amount of medication. Certain children are larger and may be able to take more, and those that are smaller would have to take less, as that we don't want to do any damage to their body, and we want to make sure that those that are larger are getting the amount of medication that they need. So that's what we're taking a look at in this chapter, is that we need to see and incorporate their weight. As we've seen a little bit last class when we were looking at calculating the infusion rate in chapter 7, we did see some per kilogram, but we're going to see that again in this chapter too. So hopefully this is kind of a refresher from that as well. So looking over on the next page, on page 316, we're going to start with making sure that we're pretty familiar with converting our pounds and our ounces into kilograms. As most of these medications, when we are looking at these questions, we're going to see that a doctor will order a certain amount of medication, so we'll just call it blank right now, a certain amount of medication per kilogram. So many milligrams per kilogram is what we're going to see. And let's just fill in that blank there, and let's just call it 5. Let's just say doctor orders 5 milligrams per kilogram. What that means is anybody who is taking this particular drug can take 5 milligrams for every kilogram that they weigh. So given a patient who only weighs 1 kilogram, pretty much physically impossible to only weigh 1 kilogram, but just to kind of show you guys what I mean by that, that means they would take 5 milligrams because it's per every 1 kilogram. However, if they weigh double that amount, if they weighed 2 kilograms, then they would have to take double this dosage, and therefore their amount that they would need would be 10 milligrams, and so on and so forth. So somebody who weighed 5 kilograms would have to take 5 times that amount. Somebody who weighed 25 kilograms would have to take 25 times that amount. So that's what we're going to end up doing at the end, but the first thing we're going to take a look at here in this first section is making sure we feel pretty good with converting those pounds to kilograms. As most of the time when we get on a scale, or when we get on a scale at our doctor's office, we get on that scale and it measures us in pounds. So if we have a patient, for instance, let's say I have a patient who is 14 pounds, little guy, 14 pounds. Before we can consider how much we can give him of this dosage that says milligrams per kilogram, we have to convert his weight to kilograms. So again, hopefully this is just kind of a refresher for you guys from last class. As we know that when we're converting pounds to kilograms, we simply just take that and divide by 2.2, taking that 14 in this case and dividing it by 2.2 would mean that he weighs about 6.4 kilograms. We'll just take these and round them to the tenths place. If you did that in your calculator, 14 divided by 2 actually gives you 6.363636 repeating. So we'll just go ahead and round that off to the tenths place there. So we'll just get in that habit. If you do get a decimal, let's just get in that habit of rounding it to the tenths place. And that's what happens every single time. What we're doing is we're simply just taking whatever their weight is and dividing it by 2.2. So if I have a patient who weighs 33 pounds, we simply just take 33, divide that by 2.2, and 33 divided by 2.2 gives us 15. So again, hopefully we're looking at this and this you guys are going, okay, Ellie, we've seen this 100 times. Quit that. If we have a patient who weighs, let's say 45 pounds, then again, we're going to take that and simply just divide it by 2.2, and that would give us 20.5 in kilograms. So anytime you have a patient's weight in pounds, we want to make sure before we do these problems, we want to know how to convert them to kilograms, and it's a simple division by 2.2, and that's because, remember our equivalent for that, our equivalent said that 1 kilogram is equivalent to 2.2 pounds, and that's why we choose to divide by 2.2 every time. Okay, so now let's see what happens. As you guys may be noticing on page 317, a couple practice problems that are asking us, what if I have something like this? Let's say, our earlier example, we had somebody that was 14 pounds. What if we have somebody that's 14 pounds, 8 ounces? Every now and then we have to take into consideration every ounce of that patient's body weight because we want to make sure they are getting the most accurate and the more, as far as being precise with the amount of medication that person needs, we want to be very exact. So for somebody who's 14 pounds, 8 ounces, there's two things we have to think of. When we're converting pounds to kilograms, yes, pounds to kilograms is simply our dividing by 2.2 like we did earlier. So we're still going to do that. We're still going to divide by 2.2, but now we have to consider ounces. Ounces is a different measurement. So let's think about ounces a little bit further. Ounces, going back to our equivalents and all of our knowns, how many ounces make up a full pound? Hopefully you guys are thinking, remember, 16. 16 ounces is what makes up a full pound. So therefore, just looking at just these 8 ounces right here, so not even paying attention right now to the 14, just looking at just the 8 ounces. If somebody is 8 ounces, that means they're half of a pound, right? So this person on the screen in front of us, you could technically say then is 14.5 or 14 and a half pounds then, because that 8 ounces is a half a pound. Now 8 might be easier to think of, as far as, we know 8 is half of 16, so half is kind of easy to do. But I've got a way to show you guys how we can incorporate those ounces into these, because what's going to happen now is, now that I know that this person is 14.5 pounds, that's the number that I will choose to divide by 2.2, and when I do so, 14.5 divided by 2.2 gives me 6.59, or 6.6 if we round that up. Whereas, not much of a difference from the person who was just 14 pounds, who was 6.4 kilograms. Really 2/10 of a difference here. But depending on the medication they're taking, that could make a world of a difference. So we want to make sure we're considering every bit of their weight. So like I said, 8's kind of easy. 8, we can think, okay, 8 is half. We know how to do half. Well, what we need to do every single time when we're looking at patients whose weight is given to us in pounds and ounces, what we need to do for just a brief moment, look at those 8 ounces out of 16. We're going to look at it as a fraction for just a brief moment, because what we're doing is we're looking at this person and we see they're 14 pounds, 8 ounces. So we know for sure they're 14 point something pounds. We look at that 8 ounces for just a brief moment out of 16 as if it says the fraction 8/16. But again, because we all hate fractions and we want to get rid of fractions immediately, we can do so by immediately turning into a decimal. Remember how we do that whenever we have a fraction, so just showing you down here at the bottom, whenever we have a fraction and we want to turn that into a decimal, we simply look at this line between our two numbers as if it says to divide. So I can take 8 divided by 16, and when you do that in your calculator, that's where that 0.5 comes in. So obviously the 0 is replaced by the 14 in this case, because this person is 14 pounds, 8 ounces, not just 8 ounces by itself. So that's why we replace the 0 with the 14. So anytime you have any amount of ounces in a weight, simply look at it out of 16 first, simply because, again, 16 ounces makes up a full pound, so it's like you're saying they're 8 out of 16, and then just turn that fraction into a decimal. So when I've got somebody who is, say, 31 pounds, let's say 5 ounces, something we wouldn't be able to just do in our head, we know for sure that they are 31 point something pounds, but I'm going to first just look at this as 5/16. Immediately I can turn that 5/16 into a decimal by dividing. My calculator gives me 0.3125. So for more, to be more accurate, you can use the whole decimal, but if you do round that off to a couple places after the decimal, you'll still be close enough, so that would be okay. But just for accuracy's sake, I'm going to go ahead and just use the entire decimal here. So that means this person is 31.3125 pounds. Still in pounds until we do what? Divide by 2.2. Remember, to convert pounds to kilograms, we still have to divide by 2.2. So 31.3125 divided by 2.2 gives us 14.2. So this person is 14.2 kilograms. And as I mentioned to you guys earlier, it wouldn't make a huge difference if you did round that off. If you rounded that off to this number here, 31.31. Let's say you left off the 2.5. If you take 31.31 and divide by 2.2, you still get 14.2. Even 31.3 divided by 2.2 gives us 14.2. So see, it's not making a huge difference. I just, like I said, for accuracy's sake, I use the whole thing. But that's completely up to you. If you want to round it, that's okay by me. So just to do one more example, just to show you, again, if we have pounds and ounces, let's say we have, I don't know, let's say a patient that weighs 41 pounds, let's say 4 ounces. One you might be able to think about, maybe even doing in your head, simply because 4 would be 1/4 of a full pound, because, again, it's a fourth of 16. But if you're not thinking about it that way, again, we know for sure they're 41 pounds, so 41 point something. Look at this, 4 ounces out of 16. If you take 4 divided by 16, it does give you 0.25. So that means this person is 41.25 pounds. This is the number we'll then take and divide by 2.2. And 41.25 divided by 2.2 gives us, this person is 18.75. You can round it up to 18.8 if you choose to do so, if you just want to round it to the 10th place. So 18.8 kilograms. So that's how we're getting our patient's weight into kilograms. So that's going to be something we'll have to do at the beginning of each of these problems, because what we're seeing in these types of questions is, just to give you an example, if, say, a patient was ordered to take, say, 8 milligrams per kilogram, that's what that little slash means there. That means for every 1 kilogram that a person weighs, they need to take 8 milligrams of drug. So, therefore, if they weigh double the amount of those kilograms, so say they weigh 2 kilograms, that means they'd have to take 16 milligrams of drug, because they need to take double the dosage. If they weighed 3 kilograms, they would have to take triple the dosage, so they would have to take 24 milligrams. And you guys see where I'm going here, that however many kilograms they weigh, they need to take times that amount of drug. So let's say we have a person who weighs, let's say, same medication here, just 8 milligrams per kilogram is the order dose. And say, so again, I'm going to show you guys how these will be set up. So they're going to be set up like all of our dosage calculation questions. So we've got an order dose, and then we have a certain amount. So say we have a medication that is, say, let's say 100 milligrams per 2 milliliters. Okay, so we know, how that medicine comes, and the question is asking us, well, how much medication do we give? What do we give to a person who is, let's say, how about 19 pounds, 6 ounces, let's say, just to get a good example here. So for a person who's 19 pounds, 6 ounces, remember anytime that the dosage tells us milligrams per kilogram, that means we're having to consider what they weigh in kilograms in this question. So that should, more than likely, that's going to be our first step, is to convert our weight into kilograms. If it isn't already there, in this case it is not, so we need to convert it to kilograms. And then what's simply going to happen is this just gets put into our dosage calculation formula. So our D over H times Q formula that we talked about before, the difference is what's happening in this particular problem is we just need to find this specific number for this specific patient. It's going to be different based on their weight. Anybody else taking this drug may have to take a little bit more or a little bit less depending on what they weigh compared to this person. So we already know our H and our Q. That's right here. Here's our H, or 100 milligrams, and our Q is 2 milliliters. So we know where that's going to go in that D over H times Q formula. Again, we're just trying to specifically figure out how much of a dosage this 19-pound, 6-ounce kid needs. So let's first turn that into kilograms. So don't forget, we know that for sure they are 19 point something pounds. We take the 6 ounces and look at it as 6 out of 16. So we take 6 divided by 16, and that gives us 0.375. So 19.375 pounds is what they weigh right now. Before we turn it into kilograms, when I turn it into kilograms, I see that they're 8.8. Because I've taken this, don't forget we have to divide that by 2.2, and 19.375 divided by 2.2, that gives us 8.8. So they weigh 8.8 kilograms. So here's what this means in this question. This means that this person who's been ordered, really everybody's been ordered this drug, can take 8 milligrams for every kilogram that they weigh. For our patient here that weighs 8.8 kilograms, that means they can take 8.8 times this dose. So that means that I'm going to take 8.8, our patient's body weight in kilograms, multiply it by the dosage of 8 milligrams, and that means our patient can take 70.4 milligrams of this drug. Again, because they're taking whatever their body weight is times this amount here, times whatever that dosage is, because it's that amount of kilograms, or that amount of milligrams, for every single kilogram that they weigh. And they weigh 8.8, so that's why we multiplied it. So that means, again, our patient can take 70.4, and that's just what gets put into this dosage calculation. So let me move some of this out of the way. So our specific order dose for this patient is 70.4 milligrams. For medication, remember that we have was 100 milligrams per 2 milliliters. So that gets put into our H and our Q. So we take 70.4 divided by 100 and multiply that by 2. Our patient needs 1.4 milliliters of this medication. It's a liquid medication. So because it came 100 milligrams per 2 milliliters, remember our unit of our quantity here will always match the unit of my answer, because our unit milligrams had canceled out. We had just had to find this based on what was ordered for our patient who weighed 19 pounds, 6 ounces. Even given the same order dose for the same drug, if we had the exact same question, say we had, again, patient needs to take 8 milligrams per kilogram of a medicine that comes 100 milligrams per 2 milliliters. Okay, so we know every patient taking this, if they took 2 milliliters of that liquid, they would get 100 milligrams. But the order dose for this patient, they need to take 8 milligrams per kilogram of weight. Let's say instead, now I have a little bit larger of a patient that comes in. Instead of in the previous question, he was 19 pounds, 6 ounces. Let's say I have a patient who weighs 40 pounds, 5 ounces. Okay, 40 pounds, 5 ounces. Well, again, what I'm going to have to do is I understand that they're 40 point something pounds. That's a decimal there. I take that 5 and look at it as 5 out of 16. Remember, 5 out of 16, we had that example earlier, was 0.3125. And so 40.3125 divided by 2.2 is how I get that to kilograms. They weigh 18.3 kilograms, which means our patient, in this question, needs to take 18.3 times this amount. So 18.3 times 8. Our patient, this particular patient now needs to take, looks like 146.4 milligrams. And again, let's fill out our H. So that was this. And our Q, our 2 milliliters, that was this. And so now we can finish this dosage calculation. 146.4 divided by 100, multiplying that by 2. This patient needs to take 2.9 milliliters of this liquid, this particular patient here. So, which makes sense. It comes as, for every 2 milliliters that they take of this drug, they get 100 milligrams. Our patient needs a little bit more than 100 milligrams, so they're going to have to take a little bit more than that 2 milliliters. And that's, what we're looking at in these types of questions. Anytime you have an order dose that says milligrams per kilogram, so 15 milligrams per kilogram, what you're doing is first, if your patient's weight is not already given to you in kilograms, you may have to convert it from pounds to kilograms first, and then from there, we multiply it by that number. In this case, it's going to be 15. Because, again, that's what we need to figure out, is what our patient can specifically take if the order dose is to take so many milligrams per kilogram of weight. In this case, again, like the example I gave in the last example, if a person weighs 1 kilogram, which is pretty much impossible, if they weighed 1 kilogram, they would have to take 15 milligrams of this drug. If they weighed 2 kilograms, they would have to take double. If they weighed 3 kilograms, they would have to take triple, and so on and so forth. So that's why that's our next step, is to figure out what specific amount each of these different weighted patients can take. And so let's do another example here. So keeping that on the screen here, 15 milligrams per kilogram is our order dose. We have a medication that comes, let's say, 250 milligrams per 5 milliliters of liquid. And let's say we have a patient who weighs, how about 80 pounds? Yeah, let's just say even 80 pounds. No ounces involved here. So they're an even 80 pounds. We need to figure out what their weight is in kilograms. So I simply just take that number and divide by 2.2. So take an 80 dividing by 2.2. They weigh 36.4. Looks like it came out to be 36.3636, repeating. So that would just round off to 36.4 kilograms. So that means this particular patient can take 36.4 times this dosage. So we take 36.4, multiplying that by 15. That means that our patient can take 546 milligrams of this drug. And again, here's our H, so the dosage that we have, and our Q, our quantity, is 5 milliliters in this case. So completing this problem, we take 546 divided by 250, and then I take that and multiply it by 5. This patient needs to take 10.9 milliliters of this liquid. So again, it's just our simple dosage calculations. All we're doing is just trying to find the specific dosage based on a specific weight, and that's what's happening in all of these in all of these problems that we're looking at here at the beginning of this chapter. That's what we're looking at. I know on the next page here. Let me see. I want to make sure that I'm on the right page. And all those questions that you guys, at least that you guys will see from me. I'm still on the converting pounds to kilograms page. Yeah, but that's what they're doing in the next couple pages, where they're trying to say, okay, well, if this is what they need, then what does a patient who weighs this amount, what do they need? But in the next couple sections, so say, well, yeah, I want to show you guys how you guys would see these. It's getting into, like on page 324, the one at the top there, but I want to, like I said, I want to show you how I'll list these for you guys. It's asking about safe dosages. And I want to show you guys how I will word these. Go actually to page 328. Go to the first, or the self-test in this section. The self-test for the dosage calculations here. So I want to show you guys what I mean by how we can test to see if it's a safe dose or not. Look at number 1. So yes, you guys will see a couple of the problems that we saw, like the examples that we did just previously, where we might just have to plug them into a dosage calculation. In this type of question, I want to know if what's been ordered is safe for our patient based on their weight. So again, we're still looking at weights and considering the weight, but you'll notice here on number 1, they've ordered amoxicillin, and it says that they've ordered just a straight 60 milligrams to take by mouth every 8 hours. So there's no milligrams per kilogram here in the order dose. We know that our patient needs to take 60 milligrams every 8 hours, which, keep in mind how many times that is in a day. If you guys, hopefully you guys are saying 3 times, because we know in a 24-hour day, every 8 hours, so if we just divide that, that would be three separate times. So our patient's order dose is to take 60 milligrams 3 different times in a day. So eventually they're going to take a total of 180 milligrams if you look at it in a whole day. So just to put this off to the side, I want to show you guys why I'm considering that and why I'm letting you guys know that. Again, that's based on the fact that they're taking 60 milligrams every 8 hours, so 3 times in a day. 60 times 3 is 180. So that's what I'm looking at just for a second here. Okay, and so then we've got a patient who is 20 pounds. Okay, so this is where we are going to have to consider that in kilograms, but let's look at this in just a second. It says the supply is amoxicillin 125 milligrams per 5 milliliters. That will come in when I need to do a dosage calculation. When it asks me to calculate the amount that's needed, if we need to know what they need to take in milliliters, we could just take D, the order dose is 60, H, and Q, and go ahead and do that. Right now, I just want to know if the order dose is safe. And how we check to see if the order dose is safe is I look at the literature, what it says just underneath that supply. It says, on the literature, it says what's safe to take is 20 to 40 milligrams per kilogram every day. So there's our safe range. Here's our safe range. But again, here's where we have to consider the weight, because we know what the doctor ordered. The doctor ordered 60 milligrams every 8 hours, which again would be 180 milligrams in a day. Obviously, 180 doesn't fit in this range. So, okay, that's wrong. But that's because it's 180 milligrams that, just a straight up 180 milligrams, whereas the safe range says 20 to 40 milligrams per each kilogram of weight. So we have to consider what's safe for our specific patient. So let's go back up to that 20 pounds. Patient weighs 20 pounds. So if we divide that by 2.2 to see what they weigh in kilograms, 20 divided by 2.2 gives us, I think it's 9 something. 20 divided by 2.2, 9.09, which we'll just go ahead and round that up to 9.1. So our patient weighs 9.1 kilograms. So how we see what's safe for our patient, going back down here to this safe range, let's see what the safe range is for this person. What we can do is we can take 9.1 and multiply it by each side of this range to see what would be the minimum and the maximum for our patient. Again, we're just specifically considered this 9.1 kilogram person. So 9.1 times 20 gives us 182, and then 9.1 times 40 gives us 364. So now we've eliminated on this literature here how many milligrams they can take per kilogram. We know that our patient specifically can take 182 to 364 milligrams per day. Oh, per day. I can't write today. Because we eliminated this part, that per kilogram. We're considering what's safe for this person. Again, it's 182 to 364 because of our patient that weighs 9.1 kilograms. So, let's go back up to that order dose. If this is what's safe, this right here is what's safe for our patient to take in a full day, let's see what was ordered for this patient in a full day. 180. Going back up to what we talked about earlier, how the order dose was 60 milligrams, but it was every 8 hours, which would be 180 in a full day. And we have to look at it per day because that's what the safe range tells us. It says per day. So the way that we test to see if it's safe or not would be to see if it falls in that range.
180 actually does not fall in that range. So this would not be considered a safe dose because they're not getting enough medication. The lowest that they could take was 182 milligrams, and our doctor has ordered for this patient to only take 180. So that's how you guys are going to be able to test to see if it's safe or not. I know 180 is not much smaller than 182, but because it doesn't fall in the range, that's how we'll determine that it's not safe. That's how you guys will see these questions from me, is I will give you these ranges, and you just have to see what the range is for your patient. Number 2 does it a little bit differently and just gives one number on that literature. It says that what's safe for that medication, for amoxicillin in that case, is to take 40 milligrams per kilogram per day. So as long as it's near that, once you calculate it based on the weight, long as it's near that. But I think that's kind of harder to judge. So I always give you guys a range. So let's, looking at another one. Let's go down to the very last one on number 10. On that same page, on page 328 there, number 10, it says what's ordered is very similar to this last one, by mouth. They've ordered 60, I need my pen back. They've ordered 60 milligrams twice a day, so BID. So again, just to think about this off to the side, let's think about what that would be in a full day. 60 milligrams twice in a day, 60 times 2, that would be a total of 120 in a day. If we need to consider that. Okay, and so just to put that off to the side, what that's going to be in a full day. Let's see, we've got the patient's weight of 12 pounds, 8 ounces. So 12 pounds, 8 ounces. Dilantin, it comes in, as far as the H and the Q, if we needed to do a dosage calculation, that would be 30 milligrams per 5 milliliters. So we could always do that calculation off to the side if we need to know what they need to take in liquid form. We could take the doctor's order divided by our H and then multiply it by our Q. They would end up taking a total of 10 milliliters. So if you're asked to tell me what, how much is needed, the amount that's needed, that's what we would end up doing for that. But to determine the safe range, let's take a look on that label. The safe range says that it's safe for any patient to take 4 to 8 milligrams per kilogram, and it is per day. So that's why we are looking at that per day up here at the top, divided into 2 doses. And they're going to do that. It says maximum dose is 300 milligrams per day. So let's see what's safe for our patient. We have a small, tiny kid here, 12 pounds, 8 ounces. 12 pounds, 8 ounces. Again, 8 ounces, looking at that, 8 out of 16. So looking at that, again, as that fraction, 8 out of 16, that would be 0.5. So 12.5 is what they weigh in pounds right now, but it's 12.5 is what we would take to divide by 2.2. They weigh, looks like 5.68. I'm going to go ahead and just round that to 5.7. So they weigh 5.7 kilograms. So to see what the safe range is for this little guy, we're going to have to take that number, that 5.7, and multiply it by each side of that range, the 4 and the 8. So I just take 5.7 and multiply it by 4. 5.7 times 4 is 22.8. And then 5.7 times 8, on the maximum end here, 5.7 times 8 is 45.6. So that means our patient, it's safe for them, we've eliminated this part of this safe range here. For our specific patient, it's safe for them to take 22.8 to 45.6 milligrams each day. Well, let's take a look at what was ordered. Even just the amount that they're taking twice in a day is a whole lot more than that range. Falls over, the highest amount that they can take in a full day is 45.6 milligrams. And they're ordered to take 60 milligrams just at one time, giving them way too much in a full day, 120. So there is no way that this is safe for this small child to take. So the answer to this would just be no. And that's what I'm looking at in these types of problems, is I just want to know whether or not it's a safe range or not. And that's how you do that, is just figure out what they weigh in kilograms, if it's not already in kilograms. If it's not, we figure out what they weigh in kilograms, multiply it by each side of that range, and see based on what was ordered for them to take if it falls in that range. If it does, it is considered safe. If it does not fall in that range, then it is not considered safe. So you all will see some problems close to that on your homework and on the final exam too. The next section, what we're looking at here is just the body surface area. This is actually going to be kind of similar to what we were just looking at with dosages based on our weight. Sometimes the dosages will be based on body surface area. What body surface area does is it doesn't just consider the child's weight, it also considers their height. So it takes into consideration that maybe they're larger, maybe they weigh more because they're really tall. So it considers that as well, that they still may be kind of skinny, but they're so tall that that's where their weight is coming from. So body surface area kind of encompasses both. And so what's going to happen is there's a calculation that needs to be done to figure out body surface area, and that's what you guys are looking at on page 329. This body surface area calculation, you guys can see at the top there, kind of strange looking, but all of our calculators should have the capability of doing this, and I will not ask you guys to memorize this formula. This formula will be given to you, because I know this is probably kind of new for us, that body surface area formula here. How we calculate the body surface area is, as it mentions there at the top, is we're going to take the square root of the weight in kilograms, so whatever their weight is in kilograms, so we'll just put kilograms times their height in centimeters divided by 3,600, and then again it's just the square root of that number. So how we do that, if say we have a patient who is I don't know, let's say 45 kilograms is, I don't know, let's say 74 centimeters tall. If that's the case, then what we're going to do is we'll just multiply those two numbers. So 45 times 74, that gives us 3,330. Divide that by 3,600, gives us 0.925. And then your calculator should have a square root function, so you just take the square root of that, and it should give you, oh, hang on, I'm doing this wrong. Oh, I lost it. Sorry. It was 45 times 74 divided by 3,600, and then taking the square root gave us 0.96. Does that sound right? Okay, yeah, that was right. It was 0.96 is their body surface area. The unit for body surface area is meters squared. So this particular individual will be 0.96 meters squared. There is another calculation. It's not in your book, and I'll provide you with both of these as well. If for any reason your body weight is not given in metrics, like on, in the book there, kilograms and centimeters, a lot of times we take patients' body weight in pounds, and sometimes we're told how tall they are in feet and inches. So the other formula for that, if you're just to jot down in your notes, the other formula, if you want to just keep it in pounds and not centimeters, in inches, you could take the same thing, square root of, but this time their weight in pounds multiplied by their height in inches. So if you're given feet in inches, keep in mind there's 12 inches in a foot, and you might have to convert that a little bit. But then it's divided by 3,000, it's 3,131 instead. So if it's in metrics, the formula that we had for that was kilograms times centimeters divided by 3,600. But if you leave it in household, then it's pounds and inches divided by 3,131. So it does not matter. Again, you'll have both of those formulas, and that 3,131 and the 3,600, those are set in stone. But that way you know that if you're given a weight in pounds, you don't have to convert it to kilograms, and a height in inches, you don't have to convert that to centimeters. You can just use the other formula. That's totally fine. So again, just practicing a couple of these. Now looking at that one, if I have a child who weighs, let's say 35 pounds. Okay, they're only 35 pounds, and let's say they are 3 feet 5 inches tall. So again, this has to be in inches in order to put this into the calculation here. So keep in mind that 3 feet, there are 12 inches in a foot. So 3 feet would be 3 times 12, and 3 times 12 is 36. So this person would be 36 plus 5 inches, so they're a total of 41 inches, if that makes sense. So in this calculation, we would take 35, multiply that by 41, since that's just what they would, or how tall they are in inches. Divide that by 31. So let's do that. 35 times 41, dividing that by 31 here, gives us 0.458, but again, we then need to take the square root of that. So your calculator can either, you have that little symbol in there somewhere. In a scientific calculator, you might be able to take the square root of your previous answer, and either way, it should give you 0.68. So they're 0.68 meters squared. That's their body surface area. The reason why we're calculating this is, like I said, it's incorporating not just their weight, but it's also incorporating their height as well, as that may come into account as to why they weigh a certain amount. So when their drugs and dosages are given, we need to consider both. So what happens is, in these types of questions, that's what's going to be told to us. It's very, very similar. I'm going to give you guys questions that say, okay, well, what's been ordered? A patient needs to take, let's say, 10 milligrams per meter squared. For a medication that comes as, let's say, 5 milligrams per 2 milliliters. So, what do we give this patient? So, let's say it was for that previous, sorry, I didn't mean to draw that on there, let's say it was that previous patient. The previous patient who was 35 pounds, 41 inches. We got their body surface area when we calculated that using this formula up here. When we calculated that, we ended up getting that they were 0.68 meters squared. So based on the fact that they're 0.68 meters squared, that means they are going to take 0.68 times this dosage. So their particular order dose is 10 times 0.68. That's going to end up being 6.8. So their order dose in this calculation would be 6.8 milligrams, and we have 5 milligrams per 2 milliliters. So 6.8 divided by 5 times 2, our answer here would be 2.7. They would need to take, we would give 2.7 milliliters to this person. So very, very similar to what we had in our weight, but here we just need to calculate their body surface area first based on these formulas, and then from there we can end up calculating what they need. Same thing with safe ranges. I probably just because we haven't had too much practice with it, I may or may not do the safe range for these, but it's very, very similar. Those questions on page 333 in self-test 4 are doing just that it's given you a certain order dose. Patient can take 50 milligrams by mouth every 8 hours. That's number one. Child is 8 years old who is 50 inches tall and 55 pounds. And the supply are 50 milligram tablets. So if we were trying to calculate the dosage calculation there, we know that they would take 50 divided by 50 times 1. So obviously they're just taking one tablet every 8 hours. But we want to see if it's safe. So on the literature it says what's safe. So again, you guys are seeing this. Here's what's the order dose is 50 milligrams every 8 hours. So again, that would be 50 times 3. So that would be 150 in a full day if we need to look at that. But the literature says that what's safe is 100 to 200 milligrams per meter squared every 24 hours, so every day. So I'm just going to write day in that one. So very, very similar to what we looked at in the most previous section. We have to consider their height and weight in this case. So since their height and weight is given in pounds and inches, we'll use this formula up here. Okay, so our the second one I gave you. So we'll take their height and weight and multiply those. So 50 inches times 55 pounds. Take that and divide by 31. And then I'm going to take the square root of that, and it should give me 0.94. Let's just round that to the hundredths place there. So they're 0.94 meters squared. So that's what we're going to do here to figure out what's safe for this person. I'm going to take 0.94 times both sides of that range, 0.94 times 100. It is 0.94, right? Yeah, 0.94 times 100 would be 94, obviously in that case. And then 0.94 times 200 would give us 188. So their safe range is 94 to 188 milligrams every day. And this would be considered safe because they were told to take 150. And that definitely falls within that range here. So this would be considered a safe dose, and again, they're going to end up taking, if you want to do the dosage calculation, they would end up taking just a tablet every 8 hours. So very, very similar. Before, it's just these new formulas that you guys are seeing here. Those might be kind of new, but again, just know that those formulas will be provided to you. I may just have you guys tell me what what their body surface area is, and then I might give you a couple problems incorporating that body surface area, but we treat it the same way we would if it was per kilogram. In this case, you might just see per meter squared instead, and I would just ask it the same way, that they can take a certain amount per meter squared, so you have to calculate their body surface area and then incorporate that into the problem. So you might see a couple with that. And that's pretty much it for Chapter 8. I'm going to stop there with Chapter 8 because I just want to consider the weight and the body surface area. So there are a couple more examples moving forward, and doing just that, putting them into a dosage calculation or determining if they're safe or not. So just know that you guys will have that. You'll see a couple questions like that on the final exam. Next week, remember next week, guys, is our ATI. We're going to take a look at ATIs together. Some things to keep in mind for the ATIs. Study your basic IV calculations. So remember the drip rate, so the drops per minute, milliliters per hour, calculating the total volume. Study those formulas to kind of remind yourself what those were. Also, make sure you're checking what we just covered today, but your dosage calculations as well. Your basic dosage calculations when needing to determine how much should be given. It's based on an order dose and how the medicine comes. The things we had on today's quiz and last week's class, keep in mind what happens when I'm asked to calculate milliliters per hour, but we're given, say, micrograms per minute, how we get it from one unit to the next. So that might be something that also needs to be looked at, as that might show up on next week's ATI. We'll do a little bit of review beforehand just to make sure we're comfortable with that, but that's all we're doing next week is focusing on that ATI. So I'll have plenty of time to talk to you guys at the beginning of class, and then there's an hour time limit on the ATI. So we'll definitely make sure we spend plenty of time reviewing and talking about it, and then I'll have you guys take it, and I'll walk around and try to help you guys with some of the questions if need be too. So just keep that in mind, but keep an eye on those types of questions, on those formulas. The things that we talked about today, last week, and the week before are some things that I would definitely make sure you're looking at. And if you guys have any questions, you guys know, email me. I am not far away, but I'll be glad to email you back. And again, like I said, I'll be here at the beginning of next week, and we'll be glad to help you guys with these. Okay. All right, guys. Have a good day.